Hello dear students, welcome to Royal Palace PU College online classes. Dear students, already we had completed all the topics related to our integrations. Okay, there were several formulas, several methods. Okay, all these things we had covered in the previous sessions. Now, in the last class, that is a very previous session, we were discussing about the miscellaneous exercise. There, in particular, we have discussed only about the indefinite integrals. Now, in this session, that is the miscellaneous exercise part 2, so we shall discuss only about the that is a definite integral formulas that we shall observe, formulas as well as their related problems. Okay, dear students, now let us start with the first problem. The first problem is very simple, that is integral from 0 to pi, okay, that is pi by 2, okay, pi by 2 to pi, we are having e raised to x into 1 minus sin x divided by 1 minus cos x here, 1 minus cos x dx. Dear students, whenever the given problem, if it is multiplied by e raised to x, whenever it is multiplied by e raised to x, we have to make use of this property e raised to x f of x plus f dash of x. That value will be e raised to x into f of x. Now, here the limits will be provided. Okay. If the limits are there from a to b, just you have to substitute the limits instead of adding the plus c here, that is the integral constant. That means here how we require to distribute this, that is very important. Now, here that is nothing but here that is a pi by 2 to pi, we are having e raised to x 1 minus sin x, you can write it as what you can write here 1 minus sin x, you can write it as 1 minus, okay, 2 sin x by 2 into cos of x by 2 I can write, okay, one thing, and divide by 1 minus cos x. 1 minus cos x means what I can write here 2, that is sin square x by 2 I can write here. Okay. Now, here I will divide it 1 divided by the whole thing, okay, and then 2 sin x cos x divided by the 2 sin square x by 2. What I will get, that is pi by 2 to pi e raised to x, okay. Then 1 divided by 2 into sin square x by 2 minus of 2 sin x by 2 into cos of x by 2, okay, whole divided by what we get here, that is a 2 sin square x by 2 I have, 2 sin square x by 2 I have. That means here sin and square get eliminates, 2 to get eliminates, cos by sin value is cot, and here 1 by sin square, okay. Dear students, what is 1 by sin square? That is cosecant square, which is equal to, that is pi by 2 to pi e raised to x, okay, e raised to x into 1 by 2 into cosecant square x by 2, okay, 1 by 2 into cosecant square x by 2 minus of what we get here cot of x by 2, okay, into dx. Now, what I will do is I will write the cot x at the beginning, or I will take minus sign outside, what I get, which is equal to, okay, pi by 2 to pi, okay, if I take minus sign outside e raised to x, then we are having cot of x by 2, okay, minus of 1 by 2 cosecant square x by 2, cosecant square x by 2 into dx. If I multiply this minus here, minus, and it becomes plus, the same as it is. Now, here we can observe that cot x differentiation, it is nothing but minus cosecant square. Further differentiation of x by 2 becomes into 1 by 2 here, into 1 by 2. So, what we get here is we are making use of this particular formula here, okay, we know that. Okay, dear students, what you can write is minus of pi by 2 to pi e raised to x into what we have here, that is cot x by 2, okay, plus of that is a cot of x by 2, okay, whole dash I can write here, okay, into dx. That is nothing but here integration of e raised to x into f of x plus f dash of x, the value will be e raised to x into f of x, e raised to x into f of x. Now, easily you can substitute the limit. So, what is the integral here? That is nothing but here e raised to x into cot of x by 2, e raised to x into cot of x by 2. Now, minus sign we are having, now we will substitute the limits, that is nothing but here pi by 2 to pi, which is equal to minus of, okay students, minus of, now I will substitute the upper limit e raised to pi, then what we have cot of pi by 2, okay, upper limit minus of lower limit means e raised to pi by 2, what we have here, that is cot of pi by 4 here, cot of pi by 4, Okay. Next, then the next value is what we have, e raised to pi as it is, cot pi by 2. What is the value for cot pi by 2? The value is 0 here, minus of e raised to pi by 2 as it is, dear students, cot of pi by 4, the value will be 1 here. Okay. That is e raised to pi. So, dear students, what we get the value, that is nothing but 0 here, minus of minus e raised to pi by 2, e raised to pi by 2. The last answer is e raised to pi by 2. Dear students, that is nothing but very simple example related to this particular thing. If this question is asked in the examination, he will ask for how many marks? 3 marks he will ask here. Okay, dear students, now let us move on with the next problem, the second problem. The second problem, see here, the problems are very similar. Indefinite and definite problems are very similar. But at the last, what we have to do is, you have to substitute the limits very carefully. That is, upper limit you have to substitute first, then minus of lower limit value. Wherever x terms are there, in that x you have to put the lower limit value there, upper and lower limit. Okay, dear students, now let us move on with the next problem. The next problem is integral from 0 to pi by 4. Okay, 0 to pi by 4, we are having sin x into cos x, okay, sin x into cos x whole divided by what we have, cos raised to 4x, okay, plus what we have, that is sin raised to 4x dx, cos raised to 4x plus sin raised to 4x dx. Now, here the problem is very simple. So, here what we can do to solve this problem is multiply and divide by I can do here. That is integral from 0 to pi by 4, that is sin x into cos x whole divided by cos raised to 4x. Here both the numerator and denominator I will divide it by cos raised to 4 here. That is cos raised to 4x plus of sin raised to 4x whole divided by cos raised to 4x into dx. Okay, 0. Now, which is equal to, here we can observe that cos, here cos cube I am having here, sin by cos it becomes tan x. What is the remaining part here? Sin by cos tan. Here cos square is remaining. Okay, cos square means 1 by cos square means what we have, that is secant square x. Okay, whole divided by cos raised to 4 by cos raised to 4 1, then plus sin raised to 4 by sin raised to 4, that is nothing but tan raised to 4x dx. Dear students, these kind of the problems will be asked in your JEE mains examination. Okay, these are all very important problems. So, here try the maximum you have to try by the direct method. Direct means you have to skip the steps here. Now, here cos raised to 4 is there, cos get elements, cos cube is remaining. Okay, sin by cos means tan, remaining is cos square, 1 by cos square means secant square. Here also directly cos raised to 4 by cos raised to 4 plus sin raised to 4 by sin raised to 4. That step I had skipped here. So, ultimately what we get is this value. Now, the limit value is 0 to pi by 4. Now, I will substitute here. Put what I can do is tan square x is equal to t here. Put tan square equal to t, I can substitute. That means what we get here, that is 2 tan x. Okay, differentiation of tan square is 2 tan x. Further differentiation of tan x becomes secant square x dx equal to dt. This 2 I can take it to the denominator. We can observe that here tan x secant square dx means what it is, dt by 2. Directly I will substitute here. So, before substituting we have to find out the limit value also, that is when x equal to the lower limit 0, when x equal to 0, tan 0 the value will be 0. When x equal to the value is pi by 4, the value for t, okay, x equal to pi by 4, okay, x equal to pi by 4 iddaga t value nagatte tan pi by 4 value is 1 here, 1 square means 1 only, bhal simple idu. Now, we shall substitute all this value in the above. What we get here, that is integral from when x equal to 0, t is also 0. When x equal to pi by 4, t is also equal to 1 here. Now, tan x secant square x dx means dt. Okay. Therefore, 1 plus here tan raised to 4 it is. But what I had substituted? Tan square. So, therefore, I can write as 1 divided by t square into dt divided by 2. Why? Because tan x secant square x dx is dt by 2. So, now here I can take here 1 by 2 common outside, 0 to 1, 1 divided by 1 plus t square into dt. Okay. Now, what is the integration of 1 divided by 1 plus t square? The value will be 1 by 2 into tan inverse of t between the limit 0 to 1, that is 1 by 2. Now we can substitute the upper limit. What is the upper limit? Tan inverse of 1. Okay, tan inverse of 1 minus of what we have, tan inverse of 0. The lower limit is 0 here. Okay, now what we get here, that is nothing but here tan inverse of 1, that is nothing but 1 by 2 into pi by 4. Okay, minus tan inverse of 0 is 0. So what we get that last, pi by 8. That is your required very simple and easy example. Dear students, in the examination what steps you can skip here? Here I can divide it by cos raised to 4 and cos raised to 4. These are all nothing but the standard kind of problems here. I can divide by cos raised to 4 and cos raised to 4. Here after this directly you can move to this particular step. Okay, that means within 3 steps, 1, 2 and 3 steps, that is last final answer you can obtain here, just within 2 to 3 steps. Only if you had practiced at the background. Okay, at the background you had practiced a lot, then only we can arrive to that. Okay dear students, now please pause the video to note it down. Okay dear students, now let us move on to the next problem. The next problem is 1 divided by x square into 1 plus x, x plus 1 here. Now here I can make use of partial fraction here. Partial fraction means how we require to solve, that is 1 divided by x square into x plus 1 equal to 1 divided by x, that is a divided by x plus b divided by x square plus c divided by x plus 1, that is by making the partial fraction. Now I will take the LCM, 1 equal to a into what we have, a into, that is nothing but here x into x plus 1. What is the partial LCM here? That is nothing but x square into x plus 1 is the LCM. Here also we have x square into x plus 1 is the LCM here. That means into what we have to multiply to get this term, that is x into x plus 1 I have to get here, that I have done here, plus b into what we have to multiply to get these two terms, that is x plus 1 only we have to multiply, that is x plus 1 plus c into what we have to multiply to get these two terms, into x square, that is into x square. This is the first thing. Now here we can observe that the denominator get eliminates. Next here we are having 1 equal to a, I will multiply it, that is nothing but x square plus x plus bx plus b plus that is c x square. Again I will rewrite 1 is equal to a into, okay, 1 into, that is nothing but here x square plus ax plus bx plus b plus c into x square. Now what I can do is, in the previous class what we are doing, we are putting x equal to minus 1. If I put x equal to minus 1, here these two terms get eliminates. Okay, that manner also I can do, that is nothing but here if I do it in that manner, okay, that is nothing but at x equal to 1 is equal to a into x plus 1 plus b into x plus 1 plus c into x square. That is when x is equal to minus 1, okay, when x equal to minus 1, a becomes 0, b becomes 0. So 1 equal to what we get, 0 plus 0 plus c into minus 1 square, the value will be c equal to 1, very simple. Now again if you put x equal to 0 here, okay, that is when x equal to 0, okay, when x equal to 0, a into 0 0, c into 0 0. What is the remaining part? 1 is equal to 0 plus b into 0 plus 1 plus c into 0. So at last what we get here, that is 1 is equal to b here, the second part. Now in case to find out the a value, that time also we have to multiply. Okay, for that purpose I had multiplied it at the first only, So now what we get here, that is 1 is equal to, okay, ax square plus ax. Okay, I will multiply it, a into x, x square plus x, that is ax square plus x plus bx plus b plus c into x square. Now here what I require now, I require only the value for a now. Okay, what I will do is, I will compare the coefficient of x on both the sides. Compare coefficient of x on both sides. That means what we get here, here x coefficient means x into what it is, that is 0 equal to, here what we have, that is x coefficient are a and b, that is a plus b. That implies here b value what we have, all it is 1, therefore a plus 1 equal to 0, a value will be minus 1. Okay. Dear students, now we got all the three values a, b and c here. Now just that implies here integral from 1 to 3. Here this value means a means what we have, that is minus 1 divided by x, plus b means what we have, that is 1 divided by x square, plus c means what we have, that is also equal to 1 divided by x plus 1 into dx. Dear students, see how the simple the complex problem we are just framing to an simple problem by making use of what it is, partial fraction. What it is? By partial fraction. By partial fraction. Partial fraction. Okay. Now it is very simple topic. Now here what is that, integral from 1 to 3 minus log x. Integration of 1 by x will be log x. Now here, okay, that is nothing but here I will read it once again, 1 to 3 minus 1 by x plus x to the power of minus 2 plus 1 divided by x plus 1 into dx, which is equal to, now here minus log x we have, log x plus x raised to minus 2 plus 1 divided by minus 2 plus 1 plus log of what we have, x plus 1 between the limit that is 1 to 3. Now here log a minus log b, that is nothing but here log a by b, log of x plus 1 divided by x here, one thing, okay. Then minus of minus 2 plus 1, that is minus x raised to what we have, minus 1, that is 1 by x between the limit 1 to 3. Now you substitute both upper limit and the lower limit. Now for the upper limit 3 plus 1 divided by 3, that is we have log of what we get here, 4 by 3, okay, minus of, if you substitute 1 by 3 upper limit, minus of lower limit value is 1 is what we get here, log of 1 plus 1 2, okay, minus of what we have, 1 by 1. Now you can open the brackets. So what we get here, that is log of 4 by 3 minus 1 by 3 minus log 2 plus 1. Now here log a minus log b, what is the value here, log a by b, log a minus log b, the value will be log 4 by 3, okay, log 4 by 3 divided by what we have, 2 here, okay, one thing, minus of 1 by 3 plus 1, minus 1 by 3 plus 1, that is 3 ones are 3, minus 1 plus 3, that is nothing but here log of 2 by 3, okay, log of 2 by 3 plus of what we get here, 2 by 3, that is nothing but your required very simple result here. Okay, dear students, so here this is a little bit tedious problem and this question will be asked for 3 marks if it has been asked. Next question we shall try here, that is integral from 0 to 1, show that it is x into e raised to x dx value, okay, find out this value. Directly we can integrate it. How to integrate? That is by parts, u into v. What is that? Integration of u into v, u as it is, integration of v minus integral of integration v into du by dx into dx, that is our integration by parts here. How we have to solve it? That is 0 to 1 into x into e raised to x dx, which is equal to x as it is, integration of e raised to x minus of integration of e raised to x into d by dx of x into dx. Now here it is from the limit of 0 to 1, that is important, 0 to 1, which is equal to x into e raised to x between the limit 0 to 1 minus integration of e raised to x will be e raised to x only, here 1, okay, that is nothing but here 1 into dx. Now here at last what we have to do is, if you substitute here integral upper limit, that is 1, okay, the upper limit value will be, if you substitute 1 here, 1 into e raised to 1 minus of lower limit means 0 into e raised to 0, okay, that will be 0 itself, minus of integration of e raised to x between the limit 0 to 1. Now what we get here, we get the value as 1 minus of e raised to x, limit is substitute, e raised to 1 minus of what we have, that is e raised to 0, Now what we get is 1 minus e, then okay, minus 1, that is nothing but the 1 minus e plus e, the value will be plus 1, the value will be e itself, okay, that is the 2 plus e, 2 minus e. That is nothing but our required result. Very, very simple example. Okay, dear students, now please pause the video to note it down. Okay, dear students, now let us continue with our discussion related to our remaining problems. The problems are very, very simple. Now let us start with the last one, that is integral from 0 to pi by 2 sin cube x dx. Now here, can I write it as 0 to pi by 2 sin square x into sin x, can I write into dx. This particular 0 to pi by 2, okay, sin square means I can write as 1 minus cos square x into sin x dx, sin x dx. Now here we have to do the substitution, that is put cos x equal to t. Okay, if I put cos x equal to t, what I can write here, minus sin x dx equal to dt. Minus I will take it to LHS, that is minus dt value. Okay. Now here I will substitute the limit, that is when x equal to 0, that implies t is equal to cos 0 value will be 1, and when x equal to pi by 2, the upper limit, okay, that implies t is equal to cos pi by 2 value will be 0. All these values I will substitute. So what we get here, 0 means it is 1 here, and pi by 2 means it is 0. Next here 1 minus cos square, 1 minus cos square means what is the value here? Here the notary value will be, that is 1 minus t square. Sin x dx means it is minus dt. Okay, we will take minus outside, integration of 1 to 0, 1 minus t square, okay, into dt. Now that is minus of, I can also make use of properties. What it is? Shifting the integrals here, 0 to 1 it becomes positive. That manner also I can do it here. Okay, I will write directly, that is integration of 1, that is t, with respect to t I am doing t minus t cube by 3, between the limit what we have, 1 to 0, which is equal to minus sign outside. Now we will substitute the upper limit, that is 0 minus 0, minus the lower limit, that is 1 minus 1 by 3. Okay. Now what we have here, which is equal to, okay, here the value will be minus sign, okay dear students, minus of 0, then here 0 minus 1 divided by, that is 3 minus 1, 2 by 3, we are having here minus 2 by 3. So the ultimately the last answer we get it is 2 by 3. That is your required very, very simple answer here. Okay dear students, now let us move on with the next problem. The next problem is, show that is or else 0 to pi by 4, okay, 3 into tan cube x dx, 3 into tan cube x dx, 3 into tan cube x dx. Now here how to solve this problem here? It is similar to this particular problem. What I can write is integral from 0 to pi by 4, 3 I will take outside, tan square x into tan x into dx, which is equal to 3 into 0 to pi by 4. Tan square means what I can write here, secant square x minus 1, secant square x minus 1 into tan x dx. I will multiply by tan, that is 3 into 0 to pi by 4. We are getting here secant square x into tan x, okay, dx, minus into tan x means again I can write it as, okay, minus of tan x dx. Now easily you can integrate. What you can integrate is substitution method you can do here. So before that substitution, I will just separate it, 3 into 0 to pi by 4, that is tan x into secant square x dx. One thing, minus 3 into integration of 0 to pi by 4, that is tan x dx. This I can solve it directly. Let us take it as integral as I here, the question I is equal to I1 plus I2, I1 minus I2 here, and take it as equation number 1. I will solve here I1 first. I1 means what we have, that is 3 from 0 to pi by 4 tan x into, okay, what we have, tan x into secant square x dx. Here I have to substitute here tan x equal to t, okay, put tan x equal to t, that implies what we have, secant square x dx equal to dt ಬರುತ್ತೆ. That is when x equal to 0 ಇದ್ದಾಗ, x equal to lower limit 0 ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, tan 0 value 0 ಆಗುತ್ತೆ. And when x equal to the upper limit pi by 4, that implies t is equal to value ಏನಾಗುತ್ತೆ, tan pi by 4 value will be 1 here. I will substitute all this value, which is equal to 3 into 0 to 1. When x equal to 0, t is also 0. When x equal to pi by 4, t is pi by 1 here. Tan x means it is t. Okay, secant square x dx is dt, which is equal to 3 into t square by 2 between the limit 0 to 1. What values we get? 3 into, okay, 1 by 2 minus 0, the value will be 3 by 2, one thing. Now, I2 I will solve. I2 is equal to what we have, 3 into 0 to pi by 4 tan x dx. Directly you can integrate, dear students. What we have, that is integration of what we have, tan x. Integration of tan x is nothing but here log of secant x 0 to pi by 4. Now you substitute the value here, 3 into upper limit. Upper limit what we have, okay, that is secant pi by 4, that is nothing but here log of root 2, one thing, minus of lower limit. Okay, lower limit will be, that is nothing but log of secant 0. Secant 0 value will be 1 here. Okay, so now what is the answer here? Log 1 value is 0, 3 into what we get here, log root 2, one thing. This is the first point. Now, what is the remaining thing that we shall discuss? Now, here we have to observe that, okay, at last that is nothing but we will put in the equation 1. 1 implies I is equal to, what is the I1 answer? I1 answer is 3 by 2, 3 by 2 minus of I2. What is the I2 value? Dear students, I2 value is 3 into log root 2. Okay, dear students. So, ultimately that is nothing but our required answer. Okay, dear students, this is all about our miscellaneous exercise. Dear students, there are n number of problems in your textbooks. So, we can't solve each and every problem here, but dear students, but I tried my maximum to cover all the important problems as far as your CET concerned, as your theory concerned also. Okay, dear students, and this is all about your integration chapter. In the next session, we shall start the next chapter, that is application of integrals. Till that, thank you.